it says consider the polynomial x cubed plus 8. So it looks like this in your book. X cubed plus 8. List all the possible linear factors. So you might have it memorized that you just take the constant term and you just list all the factors of the constant term, like plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. There's no other ways to multiply to make 8, so it would be that. I'm going to list them all out for you and tell you why you do it that way. So the reason that the linear factors have to be factors of 8 is because when you do your Polydoku, you're trying to, like, it was just x cubed plus 8, so I had to put in some zeros for the x squared and the x. The reason you have to put the linear factors as something that divides evenly into 8 is because to complete this division and to have no remainder, this has to end up being 8. And so this can never be 8 if you've got like a 5 here or something, because 5 times what is 8? So the possible linear factors would be things that go evenly into 8. They would be factors of 8, like x plus 1, x minus 1, x plus 2, or x minus 2. Not x plus 3, because 3 doesn't go into 8. X plus 4 or x minus 4. Not x plus 5, because 5 times nothing equals 8, except for a fraction. 6 doesn't go evenly into 8. 7 doesn't go. So just 8. X plus or minus 8. So if I were trying to factor this original x cubed plus 8, these are all the things that it could possibly be. I would never bother trying anything else besides these. And so your book says list all the factors. So this is the answer to letter A. And then it says, is x plus 8 a factor? Well, x plus 8. So I already kind of did it here. So you start out with all these boxes blank, and then you just say, you put the x cubed here, and you hope the 8's going to end up here. So you go x plus 8, because they asked us to check that one. And then you put your x cubed here, and x times x squared equals x cubed, so that forced this to be x squared. Then you had to multiply these two together, and you get this. Well, since that has to be 0, I was forced to put a negative 8x squared here to make these add to 0. And that forces this to be negative 8x, because x times negative 8x is negative 8x squared, and it forces this box to be 64 because 8 times 8, right? And then in order for the x term to be 0, this has to be positive 64x, because when you add them, they have to equal 0. And then that kind of forces this to be 64, so we know 8 is not a factor, because 8 times 64 doesn't give me an 8 in there. So I'm going to say x minus 8 is not a factor. Hey, is there an easier way? Well, I don't know if it's easier, but there's another way. You could say x cubed plus 8. And I can plug in, I think it would be negative 8 right here. And if I plugged it in and got a 0, then I would know that it's a factor, but it's not going to work out. Because this seems even harder to me. Now I have to go 8 times 8 is 64, but I don't really know what 64 times 8 is. So grabbing the calculator. Well, that's 512. So this gives me negative 512 plus 8. I don't really have to work that out. I know that's not 0. So that's another way to say, that's called the remainder theorem. The remainder theorem says you can just plug it in. If the factor is x plus 8, then the solution would be negative 8, but we see that when we plug the negative 8 in, we don't get 0. There's a remainder. So 8 is not a factor. Or x plus 8 is not a factor. So then the next thing it asks us to do is, it says, is x plus 2 a factor? Show how you know without graphing. So you can't use Desmo. So x plus 2, let's check that. X plus 2 and x plus 8 were both on our list of possible factors. So we'll see. So remember, it has to be 8 or x cubed plus 0x squared plus 0x plus 8. That's what I'm trying to divide into. So I can put the x cubed here. I'm hoping to get an 8 in here, and it's possible. I've got a 2 here, and I don't know what's going to be up here yet. So the way you start these out is you go x times what is x cubed? Well, x times x squared. And then now that you have that up there, since this is a multiplication box, x squared times 2 is what has to go here. And since the squared terms come from these two boxes, and they have to add up to 0, that forces me to make this one equal negative 2x squared. And then I multiply x times something equals negative 2x squared. Well, that would be negative 2x. And that forces this box to be 2 times negative 2, negative 4x. And then this box plus this box has to equal 0 for the x term. So this has to be 4x. And x times something equals 4x. So this will be 4. And we hope that this ends up being 8. 4 times 8, and it is. So now we know that x plus 2 is a factor. So actually, if I wanted to write it out, I could say x cubed plus 8 is equal to x plus 2 times, like that. But I'm just going to say, yes, x plus 2 is a factor. Okay, and there's another way to do this. If I didn't want to do all the division, I could do it by going like this. Oh, wait, here, let's make this x squared plus 8. If I plug in negative 2 here, and if that makes y 0, then I know it's a factor. So in this case, maybe this would be the faster way to do it anyway. Negative 2 times negative 2 is 4 times negative 2 is negative 8. Oh, okay, so that's called remainder theorem. Which also just shows that x plus 2 is indeed a factor.